Okay, so good afternoon, everybody. So last time I start to explain sequential circuits. Okay, so starting from chapter 5 and chapter 6, you are going to see sequential circuits. It's a different type of what it's still logic circuits, but they are different from what you have seen before. So as I told you before, logic circuits we can classify them into a combinational, and that's what we did so far in this course. And now in chapter 5 and 6, we are going to do what we call sequential circuits. Okay, I don't want to scare you. Nothing is difficult, but comparing to combinational circuit, sequential circuit are a little bit harder. Nothing is hard. Once you understand, it should be okay. But I just want to tell you, try to put more effort and to try to focus on the sequential, because they are not as straightforward as the combinational. But again, nothing is difficult. You got what I'm saying? But it's a little bit harder, okay? So the main difference between them is what we did in combinational circuit, whatever the circuit is, where you have input and then you have output. The output can be only one, or can 2, 3, whatever it is. And the output here is actually depends only on the input. That means for the same input, I'm going to get the same output. Only depends only on the input. This is combined, and this is actually what we have done so far in this course. That's combinational circuit. In sequential, okay, as you will understand better in chapter 5 and chapter 6, we have what we call a state. So now the system in a certain state, okay? And now the output here, it depends on the inputs plus the current state. You got what I'm saying? That is why you'll understand as current state means which is like the last output you got. You will understand what it means anyway, but here, so this current state is the last output you got before, okay? So as you will see, that's why maybe it's still somehow early. That's why as in the future, I will draw a figure like this one here, okay? Yeah, we will have a figure like this one to show you the states. For example, the system in the state 0, 0, okay? And then either it go to 0, 0, or it's gonna go to this state. You got what I'm saying? So we are gonna move from one state to another. And the output, it depends not only on the input, but also the current state. You'll understand better what I mean, but you should know, at least for now, you should understand we are dealing with a different type of logic circuit than what we did before. That you should understand, okay? And then what I said last time, one of the main component of these sequential circuits is actually latches and flip-flops, okay? So actually all sequential circuits, we're gonna lose latches and flip-flop in them, okay? So what do you mean by latch and flip-flop? Very simple. It's a logic circuit, latch or flip-flop. By the way, flip-flop or latch are the same thing, but there is a small difference between them. I'm gonna explain it, but it's the same thing. There is a small difference. I'm gonna explain it. So latch or a flip-flop is just a logic circuit. This logic circuit is a storage unit. Storage, okay? It's going to store every flip-flop or every latch can store 1 bit. This bit can be 0 or 1. Very simple. A storage unit, right? You can store 0 or 1. And it's going to keep, if you store 0, it's going to continue 0 until you turn the power off. You got what I'm saying? So it's not like your flash memory. It's not permanent. It's not permanent. Once you turn the power off, you are going to lose it, okay? So here in latches, I started last time to explain different types of latches, but before I continue, as you will see, there is a small difference between flip-flops and the latches. And actually, most of the time we're going to use flip-flops, not latches, most of the time. You will understand why, okay? But the reason I'm explaining latches, because as you will see, we're going to use latches to create flip-flops. So latches can be like the building blocks for flip-flop. Anyway, both of them just a storage unit, but you will see the difference as I explain them. So the first type of latches I explain, we call it SR latch. S here stands for set, and reset, RR reset latch, and we can do this way, okay? And as you see here, regardless what it's a block, regardless what you have here, you have two inputs R and S, and you have two output Q and Q prime. So always you can tell Q prime and Q, right? So this is a Q is a stored value. This is a bit, stored bit, okay? And this is the opposite of it. And then I give you here in chapter 5 and 6, I'm going to use different terms than the terms I used to before, okay? So here we are going to have what we call a characteristic or a characteristic table or a function table or something like that. Anyway, so the way this one works is this way, okay? As you see here. If the input is 0, 0, okay, that means there is no change. No change in what? No change in the stored value. If storing 0 is going to continue 0. If store 1 is going to continue 1. No change, okay? And if you put here 0, 0 at S and 1 at R, you are going to make a reset. So 1 is going to make a reset. That's why I'm saying here it's active high, active high. If the one here is 1 here at R, you are going to make a reset. If the one here at S, you are going to make set. That's why it's active high. Is that okay? So the last case we have, which is 1, 1, and I told you this is a forbidden case. You should not use it. Because if you put 1, 1 here, the outputs are going to be 0, 0, and this is not allowed because it has to be the complement, right? It can't be 0, 0. It has to be Q and Q prime. That's why it's not used. So the way, so you have only, you should, if you are again, I don't think we are going to use SR, but this is a building block. We are going to modify it as you will see right now. But if you want to use it, you have to keep it here. You have only to use these ones. Okay? Any questions? Very important to understand, to know how it is made. Very important to understand this table here. Also to explain, I did a lot of things here. So yeah, this one can explain very well. So if you put here 0, 0, as you see here 0, 0, no change. What no change means? It means if Q is 0, okay, so the new Q, after you apply this input, the new Q is going to be the same. That's why I'm saying no change, okay? If you put here 1, as you see here, so you are causing a reset. That's why if the input here, whatever, regardless of whatever input you have here, is going to be a reset. Okay, here is going to be a set. So regardless of whatever you have here, is going to make a set. 1, 1, as I told you, this is a forbidden case. Okay, and also this I will in quizzes in exams, I will give you something like that. Okay, so I'm going to give you, I'm going to ask you to give me Q. I just want to test you if you understand how it works or not. So for example, I'm going to give you S and R. I ask you to draw Q and Q prime. Is that okay? Something like that. Very important. This maybe in combinational circuits, we did not use a lot of timing diagrams, but now it's starting from the sequential, we are going to see a lot of timing diagrams, okay? Because we need them here. Anyway, I made clear last time also, I told you, although most of the time I'm going to assume the signal is perfect, everything is perfect. That means in reality, I'm gonna assume it's perfect because, just to make it easy for you to understand. But in reality, you should understand that you can't have something like that. There should be a rise time and there should be a full time in reality. Also, what I'm saying here, you are gonna have a change here immediately. It's not gonna happen, right? So there should be a delay. There is some delay here. I'm just ignoring it because to understand the functionality of flip-flop or latch or whatever, it may be easier to do this way. But you should understand in reality, it's a change. It's not going to happen immediately. There is a delay. Okay. Anyway. And then what I did also last time, I told you we are going to have an NAND, as you see here. I can also create SR latch using NAND this way. And by using NAND, it becomes active low, not active high. That is why we are again have a new table here. As you see here, when S is 0, okay, so it's gonna make a set. When R is 0, I'm gonna make a reset. 1, 1, no change. Okay, 0, 0 is the forbidden, not 1, 1. So it's exactly same thing, but we just made some changes here. Instead of 1 was instead of active low, it becomes active. Instead of active high, it becomes active low. Okay. Any questions? And then also I took this one, which is this is the SR using NAND. I took it and then I added this part to it. So look here what I did. I just added this part. I added this part so that I can have an enable. You answer. So enable for anything. If you enable it, it's gonna work normally. If you disable, it's not gonna work. Okay. So the way I did it here, and now this is the table. Now look at the table. If the input is 1, that means if the enable is 0, that means it is disabled. So if you put here 0, as you know, in case of NAND, you have 0 here and 0 here. So regardless of what you have here, it doesn't matter. Regardless so you are gonna have here 1 and 1. Is that okay? 1 and 1. And if you go back here, you see 1 and 1 is gonna make no change. You know what I'm saying? So if it is disabled, that means no change. Yes. So then if you put here 1, you actually enable it. Is that okay? If it is enabled, it's gonna act normally, like this one normally. Okay. So let's see. So if it is enabled here, it's gonna work normally, but because we change it, I changed the architecture here, it's gonna be active high instead of active low. Okay. Here, this part is active low. But if you see it from here, it becomes active. This part is active low, okay? But this part from here is going to be active high, as you see here. So if you see here, if you put 0, 0, okay? So now 0, 0 is actually not change, okay? Because I put inverter here, okay? So it changed it. As you see here, when it is 1, look what happened when it is 1. So actually, I input here S and R, but what's going to be input here for this part is actually S prime and R prime. It's like exactly like this one here, but I flipped these ones, okay, because of the part I added here. Anyway, it's a small difference. So this one is exactly similar to what I explained to you before. The only difference, it became active high. Okay, that means if the one is at R, it becomes reset. If the one at S, so it becomes set. Okay, 1 1 is forbidden. Okay. Any questions? Okay. And if you look at if you have a table like this one, if you have a timing diagram this one to understand how it works, it's very simple. Look here. Here the enable is 0. What it means? It is disabled. So in this part here, it is disabled. Is that okay? But here it is 1. That means it is enabled. Okay, very simple. If it is disabled, what it means? It means Q will be the same. Don't think about it. Don't think what is R, what is Q, or what is R, what is S. Okay. So here I start from Q of 0. This is the beginning. So it's going to continue 0. Regardless, don't look at these ones. Don't look at the S and R because it's disabled. Okay. So in exams, if I give you something like that and you see E is disabled, all what you have to do, so I start Q of 0. So it's going to continue 0. Okay. This one is 1, is going to continue 1. Don't look at R and S. Very simple, right? And this part here is different. This part here, it is enabled. You see, it is enabled. It is enabled. Now you are going to use this table. Okay. So you can see here 1 1 0. So 1 0 is going to make a set. That's why you can see a set here. And now it is 0 0. 0 0 means no change. Here, because it is high, it's going to continue high. Okay. Now it is 0 1. When R, if you look at the table here, 0 1 here. Okay. So it's going to make a reset. It's active high. So the one here at R. Okay. So that's why this one is going to make a reset. Reset this one. Okay. 0 0, no change. It's 0 is going to continue 0. Okay. 1 1, this is a forbidden case. Is that right? So 1 1 here, it becomes, I think, yeah. So this is, I told you, I think, yeah, 1 1 here, this is the forbidden case. So I'm not gonna, I think we can stop here, okay? So I'm not gonna, because you should not input this one. So I'm not gonna waste time to think, okay, if you input it, what will, and we're gonna solve this problem anyway. So having this input, it's a problem. And I will see you how can we fix it, okay? So I'm not gonna consider this case anyway, okay? Yes. In forbidden case, okay, in forbidden case, if you input here again, If you input here 1 and 1, okay, and this one is 1, so you're going to get here 0 and 0. Is that okay? And then if you have here 0 and 0, you're going to have 1 and 1 here. You understand what I'm saying? That's why what I did here, when I had here 1 and 1, okay, so I got here 1 and 1. Okay, but anyway, I hate to talk about this case because again, this is a forbidden case. You should not consider. And we're gonna solve it right now. This is like a basic latch. I'm gonna modify it right now. You got what I'm saying? To avoid to cancel this. This is like a problem. It's a problem. Okay. So anyway, so the second one. So now here in latches, there are different types of latches, but the very common ones, the very popular ones are SR latch and D latch. Okay, D latch is very important. So now I'm going to talk about D latch. You will see. So now how D latch is different from SR latch. Look here, it's very small difference. Look, it's exactly same thing like this one. Okay, but I'm going to solve this problem here in D latch. So D latch is going to solve this problem. How we are going to solve? I'm going to do very little modification on this one. Okay, so what I will do, instead of having 2 inputs, I'm going to have only 1 input. Okay, so I'm going to have here 1 input. I'm going to call input D, and then this one here is going to be connected here. I'm going to put inverter here. Okay, that means it's exactly something like here, but you are going to input here D, and you are going to input here D prime instead of S and R. Is that okay? So again, I'm going to do very little change to this one. I'm going to make another flip-flop. We call it D flip-flop. In D flip-flop, we don't have 2 inputs. We have only 1 input. We call it, it has D. Okay. And the way, as you see, the way you are going to do it, here you are going to have D, and here you are going to have D prime. Okay. By this way, it's impossible to have 1, 1, because I have inverter here, right? So whatever you put here, I'm going to have 1 value here, and the complement will be here. So I'm not going to have 1, 1. We're going to cancel this case. So let's see how, so if you look at the flip-flop, it's, sorry, if it's the latch will be something like that. Still, we have an enable. And instead of having 2 inputs, it's going to be only 1 input D. Still, we have Q and Q prime. That's it. So let's see how it works. Very simple. I'm going to tell you how it works. Let's start with, for sure, the enable one here. Okay. So if the input is 0, again, this is similar to what we did before. It is disabled. Disabled means because this one is 0, this one is here is 0, and then I'm going to have 1 and 1. And for this one, don't forget the truth table of this one, okay? And for this one, if you have 1 and 1, that means no change. For this one, if you go back here a couple of slides, I think I put it here. No, I didn't put it. Yeah. Yeah, if I go back to this one here, yeah. So if you see here, yeah, this is function table for this one. In case of 1, 1, no change. Is that okay? That means if there is an enable, we're gonna put here 1, 1 and make no change. Is that okay? And then, yeah. So this is disabled. Okay. If it is enabled, now if it is enabled, so what's gonna happen? We're gonna have D here, and then we're gonna have D prime here. Okay. So let's see here. If D is 0, this is the first case, D is 0. That means we're going to have 0 here, and then I'm going to have 1 here. Because you have 0 here, I'm going to have here 1, and then I'm going to have here 0. Okay. And this one, because this one is 0, you are going to have here 1, and then you are going to have 0, which is going to make a reset case. Okay. So you can just follow the gates. Very simple. If D is equal to 0, put here D is equal to 0. You will see, okay, you will see the output here is going to be reset. The output is 0, okay? If you put D of 1, the output becomes 1. Very simple table here. So again, very simple. So by this, because you have only 1 input, now the table is very simple. The table is telling me, number 1, look here. If the enable is equal 0, that means it is disabled. That means no change. Very simple. This number 1. Number 2, if the enable is equal to 1, Q is equal to D. Very simple. That means if D is 0, Q is 0. If D is 1, Q is 1. Very simple. That's what we call a D latch. and we don't have the forbidden case. Any questions? Any questions? Okay, it's the same thing, but I'm explaining it in a different way here. I'm telling you, look here. If the enable is 0, is that okay? So if the enable is 0, so regardless of what D you have, regardless of the value of D, okay, so Q, the new Q is equal to the old Q. So if the Q is 0, I'm going to keep it 0. 1 is going to become 1. 0 is going to be 0. So no change. You understand what I'm saying? So what I'm saying here, if the enable is 0, so regardless, D doesn't matter what is D, okay? So there will be no change. So that no change means if Q is 0 is going to continue 0, 1 is going to continue 1, 0 is going to continue 0, 1 is going to continue 1. Is that okay? Look at this case. If E is 1, that means it is enabled, okay? When it is enabled, now, very simple, Q is equal to D. Very simple. That means if D is 0 as you see here, so regardless what is Q, I'm gonna have 0. You are gonna make a reset. Same thing, if D is 1, so regardless of what you have here, Q is 1. D is equal to Q. Very simple. Any questions? Yes. That's a bit, because I created this one to solve the problem of the forbidden. You got what I'm saying? No, which one? Wait a second here. Where is your one here? You got what I'm saying? Because I don't have 2 inputs. This is different from what I had before. So I don't have 2 inputs. I have only 1 input, right? So before 1 was 2 inputs, S and R. But now I don't know what you mean by 1 here. You got what I'm saying? We don't have 1 here. This input is only 1, but this is Q, the value of Q. So regardless what is the value of Q, you are gonna get 1 anyway. Okay. Any questions? Okay. So I explained here how can you create the D latch using. Look here, this is the building block. This one is the building block. I just did modification to this one, okay? So this one is the SR. That's why I told you the SR is the building block. So here I used SR to create the D latch. So, and as I explained before, for SR, we have SR using NAND and we have SR using NOR. So still I can create the latch, the D latch using NAND or NOR, okay? So now in this slide, I created it using NAND. Can I do this ignore? The answer is yes, you can. And it will behave exactly same thing as you will see right now, okay? So here, that's what I'm explaining in this slide. I can create here SR latch here, but I can make it using NOR. Here also, this is the SR latch, by the way. So this one is the SR latch, but I did it using NAND. But in this case, if you want to do it using NOR, I need to do some modifications here. So instead of using NAND here, okay, and instead of using NAND, I'm going to use AND, okay? Yeah, so look how it looks like. So this is the SR latch, which is like this one. And this is the table for this latch. And this one has for sure forbidden case. But out of this one, I'm going to create the D latch, as you see here, which if you look at this one is exactly similar to the one I put here, but to give me the same table here, and instead of using NAND, I used AND. Okay, so let's see. So as you see here, is very simple. So if I make enable is 0, okay, so you know this is AND and AND. So 0 is gonna produce here 0 and 0. Okay, if you look at the table here, 0 and 0 is gonna make no change. Is that okay? But if I make this 1 here, so we're gonna have D here, and then we're gonna have D prime here. And as you know, if you have here 1 and D, so I'm gonna input here D, and then I'm gonna input here D prime. Okay, that means if D is 0, you are gonna input here 0, and then you are gonna input here 1. And if you look here, 0, 1 is gonna make a reset 0. That means if D is 0, Q is also gonna be 0. So again, if you look at the truth table here, you will see the truth table here is similar to the, so I shouldn't use the truth table, function table, for example. So the function table here will be similar to this function table. Is that okay? I just want to show you I can create the D latch using NAND SR, okay, latch, or NOR SR latch, but the truth table will be the same. And the truth table, I'm gonna make it very trivial. Number one, if the enable is 0, so no change. If the enable is 1, so very easy. Q is equal to D. If D is 0, you store 0. If Q is 1, if D is 1, you store 1. Very easy. Okay, guys? Any questions? Okay. So here, I just, again, in this part, we like too much the timing tables because, the timing diagrams, because this is the way we can explain this topic, okay? So let me explain it, how it looks complicated. It's very trivial. It's not, it looks complicated, but it's very trivial. I'm going to tell you, if you understand it, very trivial. So see how I'm going to explain it. Look here, guys. Very simple. I have two cases, enable or disable. Disable, no change. Enable, Q is equal to D. Very trivial. So now if you look at this part here, disabled, 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 disabled. Okay? So these are the parts of disabled. Okay? Disabled, 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 disabled. So in these parts will be no change. Okay? No change means if in the very beginning, I start from 0, so I'm going to have 0. Regardless, I'm not going to look at G. It is disabled. I'm not going to look at G. I'm not going to look at G. I'm not going to look at G. It's disabled. Okay? And then in this part here, guys, because it is high, I'm going to continue high. In this part, because it is low, it's going to continue low. This part, because it is low, it's going to continue low. It is disabled. Very easy. So in case of disabled, so disabled, you regardless of D, see what is Q, and it will be the same. See what is the last Q, it will be the same. Is that okay? This part is here, it is enabled. In this part is here, in this part here, here, and here, and here. It is enabled. In case of enable, Q is equal to D. That's it. And that's what I did. Look here. So these are the enabled part. Here, from here to here, it is enabled. From here to here, it is enabled. From here to here, it is enabled. So what's going to happen? Look here. It's equal, right? It's equal. D, Q is equal to D. That's how it works, right? If you look at this one here, it's equal. Okay. Same thing here. If you look at this one, okay, it's equal. Okay, guys. And always Q prime is a flip if it's a complement of Q. Okay. Any questions? So it looks difficult, but it's very trivial. You got what I'm saying? So you need to know which areas. In quizzes, I will give you something like that. I can give you D and Q and ask you to make Q and Q prime. That's it, right? So you see which areas that it is enabled, which areas are disabled. In the disabled, see what is Q. It's going to be the same, no change. Always Q prime is the flip of Q, always. Okay. In case it is enabled, Q is equal to D. Any questions? Good. Yeah, sure. Yeah, you need to draw everything. So I'm gonna give you this D and E in complete, and then I'm gonna ask you to do this too. Yeah, it has to be complete all the time. Okay. So if this one is disabled, I want to see what, for example, here it is disabled. I want to see what is the value. Okay. Maybe you are confused a little bit. Disabled does not mean the storage unit is not storing anything. No, it doesn't mean that. It's still you are storing something. So still I can get some output here. You get what I'm saying? But it means no change. If you're storing 0, it's gonna stay 0, but still you have something to get. Okay, and maybe this is what confusing you. Any questions? Okay. Again, so what I'm gonna do now, I'm gonna go to flip-flop. You will see I'm going to do little modification to latches to make flip-flop, okay? But what is the main difference? Flip-flop and latches, what is the main difference? I'm going to tell you the main difference, and please pay attention to this one because it's very important. We're going to use it all the time, okay? Latches and the flip-flop, both of them are storage units. Every latch or every flip-flop is storing one bit that can be 0 or 1. They are similar here. Okay, so what is the difference? I'm going to tell you what is the difference. Look here. The difference is, as I explained here, look here, guys. For example, look at the enable part here. Okay, the enable part is for sure. Look here. Here, once D changes, Q change right away, immediately. Yeah, there is a small delay, we ignore it. That's okay. But once at any time, when D change, Q change, okay? Q change. So at any time, right? D change, Q change. Same thing here. When here it was 0, this one was 0. It goes to up, this one is 1, okay? So always Q is equal to D all the time. Is that okay? We don't like that. Why you don't like it? I'm going to tell you why. To make synchronization, to make the circuit synchronized. Synchronization is very important, as you will understand later, okay? So to have synchronization, I don't want the flip-flop to work all the time like this one. I want it to work. Okay, what work means? Work means Q is equal to D. Okay, I want it to work at specific times for synchronization. What it means? I'm going to tell you what it means. The main difference between flip-flop and latch is, in latch, the output is going to change immediately after you change the input. But in flip-flop, no. I want this thing to happen at specific times for synchronization. That is why we're going to have a new input right now. We call it a clock. So we are going to have a new input. This input, we call it a clock. Okay. So what is a clock? Clock simply is just a square wave. Square wave this way. It's a new input. Okay. And now we have two types of flip-flop. The first type is the change can happen only at rising edges, here or here or here, at rising edges here. Not all the time. So the main difference between latch and flip-flop, in latch, once D changes, Q changes right away. Here, no, D change here, but Q is going to change here. Only Q is going to change at specific times. So even D changes before. So if D change here, Q is not going to change. Only Q is going to change at these specific times. Is the only difference. How you make it? Okay, that's what I'm going to explain. But the only difference is the Q is going to change at specific times, not all the time like latches. Okay, and now we have two types. One type, it works here only at these specific points here. Q is going to change at these specific points. That's what we call a rising edge, okay? Or sometimes we call it positive edge. Yeah, so sometimes we call it a positive edge, or sometimes we call it a rising edge, okay? We have, as you will see, we have other type of flip-flops that is going to work at the falling edges, okay? So we have two types, okay? Again, you can use whatever you want to use or whatever can serve your design. So for example, if this is a clock, so here, this one is going to act only at falling edge. So the Q value can only change here. The D value can change at any time. So the D value can change here, at any time. But the Q value is not going to be updated except only at these specific points. Okay, you understand the difference? But why is this a good idea? But because you are going to introduce a delay. Okay, so if D changes here, you not have to wait until this one comes to change here. You are going to introduce a delay. Okay, my problem now is not a delay. If you think about it, by the way, all digital systems have a clock. Okay. By the way, when you buy your laptop, they are telling you your laptop is 2.5 gigahertz. What is this? This is a clock. You got what I'm saying? This is a clock. So the reason we need a clock for synchronization. If you want to do something, if you want to do addition, subtraction, if you have a big system, we need to synchronize. Something cannot happen before something else. They have to be synchronized. So I want the flip-flop to work at this specific time so that the output will be taken by someone else to do something else. You understand what I'm saying? So it's only for synchronization, to synchronize things. So I don't want to flip-flop to work before this point. And usually it's the same one. The same clock is to connect it to every circuit to make synchronization. It doesn't make sense to connect different clocks, okay, because this is not going to make synchronization. Okay. Anyway, any questions? So all what I'm going to do, nothing is new. All what I'm going to do, I'm going to show you how this is the D flip-flop. Sorry, this is the D latch. This is the D latch. The D latch, once you change X here, Q is going to change immediately. Okay. I'm going to show now how I'm going to modify this D latch to create D flip-flop. And to do that, I'm gonna have a new input. I'm gonna call it clock. And I'm gonna show you how you will force the hardware to take action only at rising or falling, not at every time. Okay. Any questions? That's what I'm gonna show. So I'm gonna do very little modification to this one here, as you see. Yeah. So here, I'm explaining the difference between flip-flop and latches. Okay. So the way I'm gonna do it here, I'm gonna use two D latches. So this is D latch and this one is D latch. So out of this D latch here, I'm gonna use two of them. Okay. I'm gonna use two of the D latches. I'm gonna tell you how it works. Okay. So inside this one here, guys, inside this one is gonna be this circuit here. This circuit. So the complete circuit D inside this block. I'm gonna use two of them. Okay. Again, the trick is how you are gonna force the hardware to change Q only at rising edges. And then I'm gonna explain later how to force it to work at falling edges, specific points. Okay, that's what I'm gonna tell you. Okay, so now we have this one here. We have D, we have Q, right? Sorry, we have enable, and then we have Q. Okay, I told you if enable equal to 0, it's not gonna work, no change. That's what I told you. Also, I told you if enable is equal to 1, Q is gonna equal to D. That's what I told you, right? So now look at the point that we made here. So all what I did, one way to design what we call a D latch, D flip-flop. Okay, so is I'm gonna start with negative edge. Negative edge means falling edge. I'm gonna show how this circuit looks like, and then I'm gonna explain also how can we create the positive edge, or it's gonna work at the rising edge. So either at falling or rising. Okay. So let's start with the first one here at the falling edge. Okay. So look how it works. So again, you know how this latch works. So this one I call it a master. This one I call it a slave. Anyway, so look how it works here. What is the point? I'm gonna connect the enable here this way. Then I put inverter, and then the enable here. Think about it. Because of this inverter, the two latches cannot be enabled at the same time. True or false? For sure, it's true. You got what I'm saying? Because if I put here a 0, so this one is disabled, and here is 1, and this one is enabled. And if I put here a 1, so this one is enabled, and this is a 0, this one is disabled. So based on the value of the clock you have here, only one of them enabled, the other one is disabled. Okay. So what I'm telling you is when I have a falling edge, only at the falling edge, Q should equal to D. At any time else no change. So if you have a clock, only at the falling edges, only at this moment, Q is going to be updated. Any other time, no change. Okay? But how you made it? Look at, very simple, very simple. I'm going to tell you how it made. Look, when you have a falling edge, guys, this way, falling edge, that means I'm going to have one here for some time, one. This one is going to enable this one, is going to disable this one. And because these two, these are latches, they are working all the time. Latches are working all the time. Once you put input, the output is gonna be, you get the output right away. Okay. Anyway, so now I enable this one. So whatever value you have here, D, this value is gonna appear here, Q. So this one is enabled, right? So Q is equal to D. So for example, if I put here 1, or I put here X, X can be 1 or 0. So now this one becomes X, but it's not shown at the output yet. This is when it is 1. At this moment, when it is 1. Once you go to 0, okay, now this one is disabled and this one is enabled, and this X will go to the output here. Did I say quickly? I'm going to say it again. Look here, guys. What happens is, if you have any input X, this is a D flip-flop. That means Q is equal to D, similar to what we had before. Okay? But it should be at specific times. Okay. So what happens is that if you have an input X, 0 or 1, it doesn't matter. This X has to jump to here first, and then it has to jump to here first. Does that make sense? What happens is that when it is high, this will happen. The first jump will happen. Okay, when it is high. Once you go to low, the second one will happen. That is why this one is gonna work only when the input when the clock changes from high to low. Because high, this one is enabled. X will come to here. Okay, when it is low, this one is enabled. It's gonna come to here. So by this way, by this simple way, only Q is gonna be updated when you have high and then low, high and low. Make sense? Any questions? Okay. So if you look at, this is the D latch. In the D latch, when it is D is equal to Q, okay? So, but here, I'm gonna have a clock here. So I'm gonna input a clock here this way. Is that okay? As I told you, this is a clock. So in this clock, the update Q is gonna equal to D. Q is equal to D only at falling edges. Only at falling edges. Make sense? Okay. And this is exactly the truth table here. So the truth table or the function table is exactly similar to what we have here. So let me say it this way. Q in the D flip-flop, Q is equal to G. Okay. Only at the falling edges. Here, any other times, no change. Any questions? Okay. One more thing you should learn, guys. Look here. So this one is gonna work at falling edges of the clock. So I have a clock here. So I want to update the storage here at the falling edges. Okay. I'm gonna show you another circuit. It's just very little modification on this circuit, so that I want to update at the rising edge. Is that okay? So what symbol you are going to use for rising? How I can know if it is rising or falling? How, if you look at the symbol, I'm going to tell you. If you look at the symbol here, if you find a triangle this way or this operator, if you see something like this, means it's a clock. So again, this is a new thing. We didn't have it before. So when you see something like that, it means it is a clock. Okay, and it means this one is going to work active high when it is rising. But if I put a bubble here, it becomes active low, or it's going to be falling. So again, very simple. So every time it's very simple. Every time you see something like that, that means this is the input of the clock, and this one is gonna work at rising. Okay. But if you see something like that, so this one is going to work at falling edges. We agree on these two symbols? Just bubble here, same thing, but you put bubble here, okay? Okay. So I'm going to show you here how it works. It's very simple. So the way it works, guys, is here, look at this table, very simple, very similar to what we did before. At falling edges, Q is equal to D at falling edges. At any other times, no change, because only is going to work at falling edges. At any other times, no change. Very simple. So if I give you this one in exam, so I'm going to give you D and clock and ask you to give me Q and Q prime, okay? How can you do it? Very simple, okay? This one is more simpler than the other ones. You know why? Because I need only to look at these moments, the moments of the falling. This is the clock. So only the change will happen here, or here, or here. Anything in the middle, no change. You got what I'm saying? So you see here, at this one here, D is 1. So Q should be 1. Okay? So even D change here, D changes here. No change here. Because we have to wait until the clock. It changes happens only at the clock. So here D is 0. If it is a latch, this one is 0, this one becomes a 0. But this is a flip-flop, not latch. So this, and then we're gonna wait here. At this moment, what is D? D is 0, so this one becomes a 0. Same thing here at the falling edge. This one is 0, so this one will be 0. That's it. So in exams, anything, this one is easier than the other one, because you need to update Q at this moment, based on the current value of G. Not I don't care about the history. I don't care. Only what is the current value. Okay. Here the current value. Here the current value. Any other times, no change. Any questions? I give you another example here. Again, only changes will happen here at rising. Okay, as you see here. So I will see here. Here at this specific moment, D was 1, so this one has to be 1. Okay, and then no change until the new edge comes, falling edge comes. Here, this one is 0, so it has to be 0. This one here, it is 1, so it has to be 1. This one here, no change here. Okay, this one here, at this moment, it is 1. D is 1, so Q is equal to D at this moment. That's it, very simple. So look what I wrote here. At falling edge moments of the clock, Q is equal to D. At any other moments, no change to Q. Very simple, very easy, right? Any questions? Okay. So last part here, I want to tell you about one of the things you should have learned in labs, how can you read data sheets and why data sheets are important. Is that okay? So if you are using a flip-flop and you read the data sheet, there are three important parameters you need. The first one, setup time, hold time, and propagation delay. Okay, so what this means, I'm making just a definition, but when you go to the data sheet, you will see what is these values. So the first one here, we call it setup time. Setup time is the minimum time the value of the D input must be maintained a constant value prior to the clock. So prior to the clock, D value, I have to, if it is 1, I have to keep it for some time. We call it a setup time. Look what I'm saying? So setup time is telling you this is the minimum time, the input of the D. You have to keep it, because one of the problem here, if you just apply input very fast, circuits need some time, right? This is, you have to be careful about it. You can just put 1 and then 0 very quickly, because the circuit is not going to be able to respond to you. So that's why these times are very important. Okay. So what I'm saying here, the first thing here, the input here, you have to keep it for some time. We call it before the edge. Okay. And the second time we call it hold time. This is the time after. So you need to keep this one for some time after the clock. You got what I'm saying? That's what we call hold time. So hold time is the minimum time you need to keep the value of D, okay, after the application of the age. Either here I'm saying positive, but I mean here positive or negative, doesn't matter. Okay. So before the age comes. So again, it's some, you need to keep the D value for some time before, and you have to keep it for some time below, after, so that the flip-flop is gonna work correctly. Is that okay? And then last thing here for sure, you are familiar with the propagation delay. Okay, so here for sure, as I told you, I just made this one easy to understand it. So here, what I said here, guys, I told you here, at this clock, at this moment, this one is 1, so this one is gonna go to low. In reality, it's not like that. In reality, this one is gonna happen just after some delay. So it's not gonna be something like that after some delay. You should understand that, okay? As I said, so it's not gonna be here, but there should be some delay. You got what I'm saying? But I just make it simple to, otherwise I don't want to complicate it, okay? But you understand there is some delay, okay? Any questions? So you can find all these parameters in the data sheet. Okay. Now I'm gonna move to the positive age D flip-flop, which exactly same thing. Nothing is new. Everything I explained right now is the same thing. The only difference is, instead of working at falling, we are gonna work at rising. Okay, so as you see here, at this moment, when it is rising age or positive ages, Q is equal to D. It's gonna work only at these times. At any other times, when it is 0 or 1, at any other times, no change. Okay, this is the only difference. But how can you make it? Okay, I can make it, number one, very trivial way to make it is, this is falling age. Just I put inverter here at the clock. That's it. So this is a very trivial way. So the very trivial way to do it, this one is falling. Okay, so I'm gonna come here before the clock. I'm gonna put another inverter here. So now everything becomes rising. It's like you flip. It's like you flip the clock. You got what I'm saying? So this is a very simple way. There is another way for sure, as I'm explaining here. You can use this one here. Okay, so how this one looks, how this one works, it's the same thing. Here, when this one, when it is 0, again, this D has to move to here and then has to move here. So this one, the first jump from here to here is gonna happen at 0. And the second jump from here to here is gonna happen when it is 1. Okay, that's why you can get the output when it is moves from 0 to 1. Okay, so how? I'm gonna tell you how. Look what I did. If the input is 0, so this one is disabled because this one is 0. This one here is 1, so this one is enabled. By this way, I can make the first jump. Very easy. You just put here 0. Once you put 0, this one becomes 1, so this one is gonna work. I'm gonna make the first jump from here to here. This one is disabled. You are not gonna see anything at the output, right? But once you go up to 1, from 0 to 1, so once this one is 1, so actually now this one is 0, so you disable this one. Now this one is 1 here. You enable this one, and now we make the second jump. That's why I need to move from 0 to 1 to make this jump at the edge. Any questions? Okay. Again, if you look at this one, it's nothing is new, similar to what I explained before, but the only difference is Q is gonna equal to D only at rising edges. Okay, that's what I did. So if I give you this one in exams, very simple. Only look at this moment here. Don't care about any other moments. Don't care, because any other moments it should be no change. So let's do it. Now here, for example, I'm gonna look at this first moment here. Okay. So at this moment, Q is equal to D. So it should be 0. And it's gonna continue until this moment. Now let's think about what's gonna happen at this moment. At this moment, now D is 1. So this one has to go to 1. And then it has to continue here. I'm not gonna think about it, because for sure no change here, for sure. Once it comes to here, I'm gonna think now. So now D is 0. So this one has to go to 0 this way, right? So now same thing here, this moment. Now this one is 0. So it's gonna continue 0. So only the change happens at the beginning of every cycle. Any questions? Okay, guys, any questions? Okay. Now, sometimes, not sometimes, all the time actually, I need to have additional inputs. I'm gonna tell you why. Okay, so now what I explained in the flip-flop, I explained we need clock. You should understand what I mean by clock. And by the way, from now until the end of the semester, I'm gonna use clock all the time, because usually clock is used in sequential, synchronized sequential circuits. By the way, I told you logic circuits can be combinational or it can be sequential. Now I'm gonna say sequential can be synchronized or asynchronized. Synchronized or asynchronized. Asynchronized means we don't use a clock, just use latches. But I think we're not gonna. This one is not very useful. So we're gonna all the time we're gonna use synchronized sequential circuits. So that's why all the time we are gonna see clocks. Again, the purpose of the clock is synchronization. I need things to happen at specific times, because it's not we don't only have one player. We have multiple players. You got what I'm saying? I need them to work at specific times to do a certain action, as you will see, right? For example, if I make a counter, so they have to change in a specific time to get a certain count. You will see later, but this is the main point here. Anyway, so I explained we need a clock. This one is okay. I explained it. I explained we need input D. I explained we have Q prime and Q. Okay. On top of that, sometimes when you buy a chip, sometimes we need other inputs. For example, here I need input here. We call it clear. I have input, we call it preset, or actually set, or preset, and this is clear. Okay, so what is the purpose of these two inputs? Okay, look here, guys. When I start a system, in the very beginning in the system, I need to initialize. I need to initialize the flip-flops. You got what I'm saying? So how can you initialize it? Okay, I can apply a signal here to clear it, or I can apply a signal here to set the initial value for Q. You got what I'm saying? So usually these two inputs are used for initialization. In the very beginning, you want a Q to before in the very beginning. You want to start from 0 or you want to start from 1. If you want to start from 0, so I'm gonna activate this one to initialize from 0, and then usually they are not used usually. Okay, or if you want to start from, or at any moment if you want to clear. So again, so now we have two special inputs. One is called clear, one is called preset or reset. Okay. This one is gonna clear Q at any time. This one is not gonna work at the clock at any time. Okay. So usually this is used for initialization when you want to initialize it at the beginning. Okay. So it's not gonna be used like a normal Q is not gonna, at this moment, I don't want the Q to be equal to D because this is a normal operation. I want to reset or I want to set. Okay. Usually this is just at the beginning for initialization. Okay. So how, okay, if we do this way, listen to me. So now the operation will be this way. You have one of three cases. Listen to me. The first case, I have 0 here. Okay. And then for sure you should have 1 here, because this is, if you see a bubble like this one, what it means when you see a bubble like this one, what it means? Active low. That means if you want to clear, you have to put 0. This one also active low. Okay. So if you have 0 here and you have 1 here, that means regardless what is the clock, regardless of anything, the output will be 0. I'm gonna clear. I'm not gonna wait for the clock. No, because this is not the normal operation. That's a reset, immediate reset, regardless of the clock. Okay. So this is one case. Second case, if I put here 1 and I put here 0. So in this case, same thing. Regardless of the clock, regardless of D, this one will be set. The second case. Third case, 1 and 1. And now this one will work like a normal D flip-flop. Normal means Q is equal to D at rising edges. Every time there are rising edges, Q is equal to D, normal. Okay? There is another case that should not happen. If you put here 0 and 0, this shouldn't happen because it doesn't make sense, right? So you want to clear or you want to set, doesn't make sense. Anyway, so now I'm gonna update the table as you see here. The first case when it is 0, 0, so this case is not allowed for sure. Okay. The second case when you put here 0 at the preset means set. So regardless what is the clock, it's not gonna wait for clock. Regardless of anything, this one is gonna immediately set. Okay. Or this is the case. I can put here 0 under clear. Okay. So regardless of what you have here, you immediately clear. Immediately you clear. The part here, this part here, this is the normal operation. This is what I explained before, the normal operation. So here, every time there are rising edges, Q is equal to D. Q is equal to D. Okay. And at any other times, no change. This is the normal part of operation. You understand what I'm saying, guys? So now, because of these two inputs, I'm going to add two new rows here. This is the normal operation I explained before. Again, don't be confused. I'm going to say it again. Listen what I'm saying. Set or clear is not going to work at the clock, because clock is used in the normal operation. This is not a normal operation. In the very beginning, for example, I want to set or I want to clear. Okay. So usually I'm going to use it just in the beginning, usually. Okay. Or if there is an error and you want to take action. So this is not the normal operation anyway. You know what I'm saying? Also, to understand it better, so I'm making this timing diagram. So let me explain it. Very simple. Look here, guys. All what you have again. Now I have three operations. Is that, are you in clear mode? Are you in clear mode? Are you in set mode? Or are you in normal mode? That's what I'm saying. So let's look here, for example. If I look here, I'm gonna look at clear. I'm gonna look at the set. I see this one is 0. So this is now I am in the clear mode. So don't think about anything. I don't care about D. I don't care about clock. The output here, Q, will be 0. Make sense? Okay. Now let's look at this part from here. This part from here to here. This is the normal operation, because here and here, right? Because here clear is 1 in this period, in this time here. This is the normal operation. Normal operation. Clear is 1, preset is 1 as well. Okay. So in normal operation, so Q is equal to D, but only at rising. The action will be taken at rising. So this part here is the normal operation. So no change here because I have to wait for this one. Only change happens here. This is a normal operation, right? So at this moment here, so what is D? D is 1. So Q becomes 1. Okay. And then I need between them, no change. Okay. Again, because this is the normal operation. But if there is a clear or set, it's going to happen immediately. But anyway, at this moment here, okay, this one is 1. So this one, or sorry, this is 0. D is 0. So this one will be 0. Okay. And now in this part here, I am not in the normal operation. I'm in the set or preset operation, as you see here. Okay. So regardless of anything, this one has to come high. And then after this one here, I'm going to go to the normal operation again, because the clear is 1 and the preset is 1. This is a normal operation. So it's going to work normally. Normally means the action will be taken here. So at this moment, D was 0. That's why this one has to go to 0 here. Is that hard? Again, if you don't do it the way I'm doing it right now, it will look messy. You will understand, how it will be high load, it will be messy. So the way you have to do it is try to divide it into modes, as I explained. This is the clear mode. Okay. This is the normal mode. And you know what happens in the clear mode, what happens in the normal mode. And this is the set mode. This is the set mode, and this is the normal mode. This is one thing. The other thing is you should understand clear and the preset happen immediately. Don't wait for the clock. But in normal operation, Q is equal to D at the clock time or at the edge. Either it is rising or falling. Here, I'm giving you example for rising, but you can work at falling if the flip-flop is falling, right? Any questions? This part of the flip-flops is very important. starting from now until the end of the semester, I'm going to use flip-flops all the time. You need to understand how they work. That's it. That's what I need from you, right? So now I'm going to explain 3 types of flip-flops. Very important. D flip-flop, you need to understand very well how it works. Then I'm going to explain JK flip-flop, okay? And then I'm going to explain T flip-flop. These are the 3 flip-flops we are going to use all the time. You need all what I need to know. I need from you to know how it works. Okay, how it works. What should be Q and Q prime, because we're going to use it all the semester. Okay. The last thing I want to explain here. Sometimes if I have a flip-flop, I want to add an enable. Work or doesn't work. Enable, like any other enable. Okay. Now we don't have an enable, so someone can tell me, no, but we had enable. No. Look here. I had enable for this latch. I had enable for this latch. And I used this enable to connect the clock. But the whole thing doesn't have an enable. You got what I'm saying? So I'm going to show you now how we're going to enable in a very simple way. Very simple. Look what I'm going to do. All what I'm going to do, look here, guys. When this one is going to work, when there is a clock, right? If there is no clock, this one is not going to work, right? Because this one is going to work at rising or falling edges. If there are no rising or falling edges, it's not going to work. Very simple, right? So the very simple way to make an enable is, at the input here, I'm going to put AND gate. And then I'm going to input here the clock, and then I'm going to input here the enable. Very simple way to make an enable. I'm going to tell you how. Look here. If the enable is 0, as you know, if you have AND 0 and X, I'm going to get 0. So I'm going to get here 0. It is disabled. No rising, no falling. It's like when you put here 0, you block the clock. When there is no clock, it's not going to work. No change. It is disabled. No clock. Because actions will be taken only at rising or falling. If there are no rising or fallings, it's disabled. So very simple. So I can use a very simple AND gate here at the input. Either you can do it externally. For example, your chip does not have an enable. Okay, you can create an enable this one. Or your chip itself can have an enable. Okay, so if it doesn't, you can make it this way. So if I put 0 here and to clock, so no clock, the input is 0. When there is no clock, that's what you should understand. No clock, no change. It is disabled. No rising, no falling, no change. It's not going to work, right? But if I put here 1, the clock is going to pass here. This clock is going to pass. Why? Because as I told you in the very beginning of this course, if I have 1 and X, I'm going to get X. Very interesting. So now all what I'm going to do, I'm going to use AND gate here. And then by putting 0, I'm going to block. I'm going to disconnect the clock. If I put 1, I'm going to connect the clock. That's how I can make enable or disable. Very simple, right? Any questions? Again, flip-flops are very important. I will use it all the time. All what I need from you, if you have a flip-flop, you need to know how can you use it. Okay. Any questions? Okay. Now I'm going to move to the second one, which is JK flip-flop. Again, you will see no difference. Still we are going to work at rising or falling edges. It's still the same thing, but the actions will be somehow different. In case of D flip-flop, this is JK flip-flop. In JK flip-flop, as you see here, we have 2 inputs. One is called J, another one is called K, right? And actually, D flip-flop is the building block for this one. So if you look at whatever inside here, you will see we have D flip-flop here, as I'm going to explain. So I'm going to use D flip-flop as a building block for this one, okay, as you will see. Again, everything I explained is the same, except action. What action you are going to take, okay? So in case of D flip-flop, I told you this very simple one. Q is equal to D. At rising or falling, so Q is equal to D. That's very simple. So if this one is 1, this one is 1, this one is 0, this one is 0, right? Very simple. But now it is somehow different. So now we have, as you see here, so now look here, guys. This is how it looks like. Okay, so we have clock here. When you see something like that, what it means this is a clock, and this one is going to be rising edge. This one, because there is no bubble, So this one is gonna work rising at rising edges. Is that okay? Because there is no bubble. Guys, as I said in the film, all flip-flops have clock. Okay, as I said, this is the main difference between flip-flops and latches. Okay, anyway. So, but the difference is here, in case of D, we have one input, we call it D. But here we have two inputs, J and K. So how it works, I'm gonna tell you how it works. Look here, I'm gonna make it very simple. First, I'm gonna start with how it works, and then after that, I'm gonna explain how we created it. But how it works, very simple. We have J and we have K. Look here, guys. When it is 0, 0, so no change. Okay, so when 0, 0, no change. That's good. So even when the clock comes, no change. At the clock, no change. Okay, this is the action. These are the actions that will be taken at the clock, at the rising edges or falling edges. Okay, 0, 0, no change. Okay, but when K is 1, 0, 1, or when K is 1, so actually it's gonna be reset. So that means Q is equal to 0. Okay, when J is 1, so actually Q is equal to 1. You are doing a set. When it is 1, 1, you are doing a toggle or flip. Again, make it very simple. It's very simple. Look here, guys. Again, this one is similar to D flip-flop, okay? Actions are going to be taken at edges, rising or falling. But these are the actions. These are the actions. 0, 0, when the clock comes, when the rising or falling edge comes, no change. When K is 1, J is 0, you are actually doing a reset. When 0, 1, you are doing a set. Okay, 1, 1, toggle. Toggle means you flip. If you are stirring 0, you are going to make it 1. If you are stirring 1, you are going to make it 0. Okay, so let's look at the table. That's exactly what I'm explaining here in this table. Look at this table here, guys. So 0, 0, as I told you, it means no change. No change means if Q is 0, 0, no change here. So if Q is 0, it's going to stay 0. Q is 1, is going to stay 1. Okay, I told you here, when K 0, 0, 1, when K is 1, so actually this is a reset. Okay, so that means regardless of what is the value of Q, we're going to have 0 anyway because it's a reset. Okay, next one here, set. This is the case of set. Okay, so that means regardless what is the value of Q, we're going to have a set. The last one here is called toggle or flip. You flip, complement. Okay, so what can happen here, let me tell you the last one here. So the last one here, when it is 1, 1, I'm gonna toggle. Toggle means if the Q is 0, when the clock comes, because action is gonna be taken only at the clock. Clock here, I mean the rising. So if the input here is 1, 1, and then 1, 1, and Q was 0, when the rising comes or falling comes, when the edge comes, whatever the edge is, when the edge comes, so I'm gonna get here flip 1. Or if this one is 1, I'm gonna get flip here is 0. Is that okay? Any questions? But why? Why is this one? And how we are gonna create it? Look how I'm gonna create it. One way to create it is as you see here. So this is whatever inside here, whatever inside the JK flip-flop. So now you know how JK flip-flop works, but this is how I'm going to create it. I'm going to create it using D flip-flop. But D flip-flop is D is equal to Q, or Q is equal to D, right? Yeah, that's why I'm connecting this part here. So again, I'm going to use D flip-flop to create the JK this way. Okay, look how it works. I'm going to explain to you very, very simple thing. Look here. Look, let's start case by case. For example, here, guys, if I put here 0, 0, 0, I told you 0, 0 means no change. Is that okay? Let's see. So if this one is 0, so regardless of what you have here, I'm going to have here 0. Makes sense, right? And this one is 0, so here is this one is 1. And as you know, if this one is 1, and then I'm going to get Q from here, so this one will be Q. So actually, this one will be Q. Whatever Q is, right? Because if you have 1 and X, so I'm going to get X. Okay? So I'm going to have Q. Q and 0 is going to give you a Q. Q and 0 is going to give you a Q because this is OR. Okay? And you know how D works. Q is equal to Q. No change. Q is equal to Q, no change. Let's see another case. For example, if I put here 1, I put here 1, I put here 0. Is that okay? So in this case, this one becomes 0. Makes sense? This one here, this one becomes 0. And again, this one becomes 0. This one becomes 0, and the 0 will come outside here. Reset. This is a case of reset. Let's have another case. For example, here, just give me 1 second. I'm gonna put here 1 and put here 0. So here, because this one is 0, this one becomes 1. Okay. This one here, Q prime is come here, so this one will be Q prime, and then this Q is coming from here. Okay. So because this one is Q is coming. Q or Q prime. What is the result of this one? Q or Q prime is 1. So I'm gonna get 1. The last thing, just give me 1 second. The last thing here, if you have 1, 1. 1, 1 should be toggle. Let's see how it's gonna toggle. So we have here 1 and 1. So if you have here 1 and this is Q prime, so actually I'm gonna have Q prime here. Okay. And here you are gonna have 0, so 0 is gonna come to here. Okay. So 0 or Q prime. So I'm gonna have Q prime here. So that means Q is equal to Q prime. Toggle. So because you know in G flip-flop, Q is equal to G. If I put here in G Q prime, so this one will come here. Q is equal to Q prime. Anyway, see you next time. Again, this flip-flop is very important. We're going to use it all the time.